Okay, so here's an update on the OSE circuit board mill. Most of the updates have actually been spending time on this G-code leveling utility, which also doubles as a machine controller. So the idea is you'll be able to load your G-code file in here with the browse button. You'll be able to connect to your machine, and you'll be able to start the probe. And what we'll do is it'll go through, automatically control the machine, gather data, and adjust the G-code to the board. The reason why we had to do a custom utility for this is there just wasn't anything available that really worked with our firmware, and it's just something that I need for other projects anyway, so it just made sense for me time-wise. But right now the most progress has been made in the machine control, which is almost entirely done. So this is a pretty basic interface that just has what we need for the mill. So as you can see right now, I've already connected. This will only show available devices, and you can choose your baud rate and then connect. But as you can see, I'm already connected. And you have all the essential functions that you would need. So I can put my increment that I want to move on these buttons. So right now this is 15 of the machine units, which as default for our model and configuration is 15 millimeters, and our feed rate is 350. So as you can see here, I have the ability to jog, so my z-axis is moving up, and so I'm moving in 15 millimeter increments. Now I can change this feed rate if maybe, say, I'm doing manual milling and I need to go really slow. You can see now it's moving very slow. So as we let that creep along, I'll point out some of the other buttons. We have set 0, which will set your current location of the head to the new milling origin. We have the spindle on and off, which will enable the spindle or disable the spindle. We have a rest function, which executes a custom code that, as you can see here, I have this little 3D printed part that the spindle will sit on, and that's necessary because this is held by belts, and when the machine loses power, the spindle will fall down. And so what you need to do is you need to click this rest button when you're done, and the spindle will automatically move to that point and rest. And because that can be important because you don't want to damage the spindle or any of the tools that are hooked to it. We also have your homing functions, home X, home Y, and home Z. So I'm just going to go ahead and click home all to put it back. So now we're homed. We also have a terminal down here where I can enter my own commands. So if I just want to move, let's just move on the X, let's move 20, and I'm going to put a F on there of 300. So I send that, and now we can see that we're moving in the X-axis. So there are responses. I think I'm going to add a setting so we can actually view these responses. So basically confirming that the command's been finished or if the end stop has been hit. And those are actually something that I want to have. Those firmware dependent commands I want to have in here, so they can actually be changed if maybe you're running a different version of firmware, and so you don't actually have to go into the source code to change that. As you can see, we also have backlash compensation, and these values, if you have this checked, these values are always going to be used whenever you send G-code and it sees movement. The send G-code command that I'll show in a couple seconds will always check for this, and so it's impossible to not, well, basically through this user interface it's impossible to not implement or to not utilize backlash for every movement. And then the help has not been completed yet. So I guess let me show you the last thing is the rest. This is what you're going to do when you want to turn off the machine. So you just click the rest button, and so it's going to home, and then it's just going to sit down. And this M84 command right here, this actually turns the motors off, so you know that it's going to rest right at that spot. And so there's a little bit of thud, but it's very minimal, and so there's not really any damage. And so now you're okay to turn off the machine. Now, looking at the code, so as I was talking, I have a very robust send G-code command that makes it very easy to hack or customize the software, because you can add buttons to the user interface, and you can go into their C++ slot and just add G-code commands so you can run scripts or any conditional function or whatever you might need. So I really designed this to be very easily hackable, and the main C right now is very small. Right now it's only about 325 lines of code. So it's very minimal, and so obviously it's not very feature rich, but the idea is to have a bare bones software that you can add features to. So you can see right here, this is the on button rest, and so it's literally just reading like a G-code file. I'm sending G28 to home all the axes, then I'm enabling relative movement, and then I'm using the movement command and appending this Z space, or so I want to go down negative 12 millimeters at a feed rate of 100, switch back to absolute, and then M84 to turn off the motors. So I think the system that's here is very robust and fairly close to completion. There's more conversion I have to do on the probing side, but using this new system, so here's our probe, using this new system, it should be fairly easy to convert my JavaScript code. I ran into a few issues just with my ignorance of JavaScript and having to go to C++, but as you can see, the machine is running off the software, and adding a button to just run the script that we load from this browse button. So when we load our file in there, having a button right here to just say run G-code that's been leveled won't be that far from what's already been built here. So this is an update on the open source Ecology circuit board mill. It's pretty close to being operational, and this utility is something that can actually, well, so another thing is this utility is something that can be used for basically any CNC machine, because they all work on the same G-code, and so it's pretty platform independent, and also since I made this hackable, it's pretty easy to add buttons that might implement codes that you need for your machine specifically. So there's the update on the circuit board mill.